In this video, we'd like to demonstrate LucidLink log structure distributed file system with Nutanix S3 compatible object storage. We'll begin in our object storage browser. Within our Nutanix hyperconverged environment, we've created two virtual machines which will be administering our file space. We currently have no buckets within our S3 compatible object storage. So we'll begin on our virtual machine 1, where we'll log into the LucidLink portal, where we've already defined our domain for our file spaces as Nutanix. Our domain is appended to all of our file spaces we create. We'll go ahead and create our first file space with two choices, LucidLink storage or bring your own storage provider. When we select our own storage provider, we'll be asked for a file space. We're going to call it file space. At this point, we select from our storage providers. We're going to select other provider and provide our Nutanix endpoint for our object store. We'll also require our region, and to ensure our naming convention between our file space and our object storage bucket, we'll supply our own bucket name, which matches our file space name. And after we select, our file space will begin being set up within the LucidLink service. Once setup is complete, we're able to initialize our file space. We initialize our file space from the client side. So first we need to download our LucidLink OS client for either Windows, Linux, or Mac OS. We've already installed our Windows client, so we're ready to launch, where we'll be prompted for our S3 compatible object storage access and secret keys. We'll provide our access key and our secret key, and we'll then be asked for our root password. Our root password encrypts our data on the client side. It is stretched to AES 256 encryption string, so we'll type a root password and press initialize. Once we've initialized, we'll open our folder and we'll find our file space mount point injected into our operating system. We'll take a look back at our Nutanix object store and press refresh, where we can see we've created the bucket we specified during the LucidLink initialization and file space creation phase. So inside our Nutanix object storage bucket, it is empty. When we create a new file, and we'll choose a text file, we'll call it data. We'll open it, we'll put data in it, and we'll close it and save it. If we look back at our object store and press refresh, we'll see we have an object. LucidLink leverages the object store in our unique block level manner. We don't do your traditional one file equals one object, put and get. We break the objects down into a block level layout. We encrypt on the client side, therefore the data is secure. If we try to open this object, which we know contains data, save it and open it in our notepad, it is encrypted. We cannot access it from the object store. Therefore the data is extremely secure. When we go back to our Windows client and open it, we have access to it from the client side. So now let's introduce our additional client. In order to leverage the other Windows virtual machine we have in our Nutanix hyperconverged infrastructure, we're going to assign this particular OS client its own individual user. So if we go to our user tab and log in with our root password, we'll be presented with our user management. To begin, we need to create a user. We're just going to call this user with a password and select Add User. Once we have a user, we now assign shares. In order to assign shares, we'll create a common directory structure that you expect to see within a file system. We'll create a data folder. Within it, we'll put our data text file. We'll create our users folder, and within it, we'll create another folder called user. To demonstrate how our access controls work, we'll also create another folder, and we'll call it private. We'll move back to our user shares, where we can create our shares for our user. We don't want to provide root path to our user. We want to provide them access to our data folder with read-write, and we also want to provide them access to their own subfolder nested within users as read-write as well. They will have no further access to the file space and the data within it. We want to also demonstrate our unique streaming capabilities, where we're able to randomly access data from the object storage in our log structured design and unique data layout without having to download the whole object and the whole file. Inside our data folder, we'll put a movie. So inside our data folder, we've got our data text file and a movie. The data is compressed, encrypted, and sent to the object store in our log structured unique block level layout. The object store is the authoritative copy of the data, so all OS clients connected to the file space liaise with the object store directly. Each user has its own credentials. Each user has its own encryption keys to access the data. Now that we've added a user, let's protect our data the way it currently is by creating a snapshot. On my desktop, I have a file space snapshot command. I'm going to trigger the snapshot at that point, and then we'll take a look at our object store. We'll press refresh, and we note we have many objects making up our 700 megabyte movie in our default block level 256 object data layout. When we go across to our second virtual machine within our Nutanix hyperconverged infrastructure, we can log in to our file space called file space Nutanix with our user called user and our password. We'll be able to open the folder, which will look entirely different to our root user file space. We only see the data directory. We only see the user folder. We have read-write access to the data folder, so we can open our text file and we can contribute user. We can select save and close. Now let's take a look at how we stream data from the object store. We put a video in from our virtual machine 1. On virtual machine 2, we're going to open our video. When we open our video, we'll note that our kilobits per second on our Ethernet traffic will move up to Mbps as we stream the data. So we'll open up our video, and we can note that as we access the data and randomly access the data, we're drawing the objects we require from the object store. As we seek to a different portion, you'll see we'll increase our receive traffic on our Ethernet in Mbps. If we move to another point, we can see it increases again as we prefetch. We'll pause and we'll drop back down to kilobits per second. If we seek to another portion of the video, we'll note it'll go back up to Mbps. And then if we resume playing, we'll start streaming the data we need as we need it from the object store out of our unique block level layout. We aren't doing full puts and gets out of the object store. When we close our video, we resume back to our kilobits per second of our traffic. If we go back to our virtual machine 1, now that we've added additional data, let's create another snapshot because we've edited our text file. Once we've completed that, let's activate our snapshots. Our snapshots you can access from the Lucid client via our Snapshots tab. However, we activated our snapshots via our script, so we'll note that our file space snapshots have appeared, where we can look at snapshot number 1, which contains our base directory structure logged on as our root user. Inside data, we can see our text file only has data. If we go to our snapshot number 2, we can look at our data and we can note that our data has user and data that we contributed from our other user. If we take a look at our other virtual machine, we can activate our snapshots. We'll have our file space snapshots mount point appear, and our snapshot 1 and snapshot 2 will look entirely different from our second virtual machine because our credentials only allow us to see data and user. So within both our snapshots, we can see only our access control privileged shares are available to that user. Let's now look at our garbage collection. We have thousands of objects in our block level layout in our object store. If we go back to our file space, we can delete all our data. When we delete all our data, our file space is going to garbage collect, clean up all the expired objects out of the object store. We also need to remove our snapshots. So we'll do that from the command prompt. And if we type Lucid, you'll see all our commands are available for scripting purposes. You can access a lot of features and functions such as creating users and shares as you saw through the user interface, and you can activate your snapshots through the user interface. We're going to list our snapshot and we're going to delete our snapshots. So we've got 2 snapshot IDs. We'll use our root password and we'll delete our second one. So you see our snapshots disappear. So now we have no data within our file space and no snapshots. Our garbage collection scheduler is going to clean up the expired objects within the object store. Depending on the amount of activity in the file space, it can take upwards of 10 minutes. So at this point, we'll fast forward. Now that 10 minutes has elapsed, we should be able to press refresh within our object store and note that all the objects that have expired from our LucidLink file space after being deleted from both the snapshots and the actual data have been cleaned up out of the object store. Thank you. I hope this has been of benefit, learning about how LucidLink integrates into Nutanix's hyperconverged S3 compatible object store and the features and functions we provide within our file spaces.